Okay, this is section 4.1, inverse functions. Remember that a function can be thought of as a matching or a mapping, they say sometimes, of the members of two sets, the domain, the x's, and the range, the y's, in which for every member of the domain, x, there is exactly one member of the range, y. So imagine that you have this little contest here with all these people and they each have a number and each person has an age, right? I mean, the kid is 12 and then the older kids are 15. Each person has exactly one age. I mean, nobody can be two ages at the same time. So this would be a function. Each person matches their number to their age. And for every number, there is exactly one age. Also, remember that if you want to figure out if a graph is the graph of a function, you can use the vertical line test, where you put a vertical line through the graph and you see if it only touches the graph one time, that means that it is a function, because for every value of x, there's only one y. It will only hit the function once, no matter where you put that line on the x-axis. A one-to-one function is what we're going to talk about now, and that is a matching where not only does every x have exactly one y, but every y also has exactly one x. So now you can see that in this particular grouping of people, each person, there are no people who have the same age. Each person has one age, and for every age in this group of people, there's only one person that goes with it. So for every x, there's only one y, and for every y, there's only one x. So that is a one-to-one function. So here's the definition of a one-to-one function. A function f is one-to-one if for a and b in the domain of f, if a does not equal b, then f of a does not equal f of b. Or equivalently, if f of a does equal f of b, then a has to equal b. All right, so here's an example just to look at a couple of functions and decide, are they one-to-one or not? Well, for part A, you can see you've got 1, 4, 2, 3, -2, 4. The domain is 1, 2, -2. The range is 4, 3, 4. And you can see that in this group, in this set, there is a value of y that has two different x's paired with it. So that is not one-to-one. And then in G, you've got -3, 4, 1, -1, 2, 0. Every x has exactly one y. Every y has exactly one x. So that is one-to-one. Another way you can see if a graph is the graph of a one-to-one function is to first use the vertical line test to see if it's a function, because if it's not a function, it's definitely not a one-to-one function. Then use the horizontal line test to see if every y has exactly one x. So if you look at this function on the far left, that is a function. We know that if you use the vertical line test on that, it's only going to hit it once. If you use the horizontal line test, however, it hits it twice. So this would not be a one-to-one function because there is a y value, 2, that has two different x's. And for a one-to-one function, every y has to have exactly one x. Every x has to have exactly one y. So no, that's not one-to-one. The one in the middle, that is a function. If you use the vertical line test, it will only hit it once. And if you use the horizontal line test, it will also only hit it once. So that is a one-to-one function. On the far right, you have a parabola. If you use the vertical line test, it is a function. It doesn't hit the graph more than once. But if you use the horizontal line test, it hits it more than once. The y, 1, has two different x's, -1 and 1. So that is not a one-to-one function, even though it is a function. All right, let's use the horizontal line test to determine if these graphs represent a one-to-one function. So if we look at that first graph, it hits it 3 times. It's not one-to-one. Here you have in the middle, when you pass a horizontal line through that function, it only hits it once. So this is a one-to-one function. Put a vertical line through it, it's good. You put a horizontal line through it, it's good. It only hits it once. That's a one-to-one function. Over here on the far right, it hits it only once going horizontally, but wait a minute, going vertically, it hits it twice. So it's not even a function. So just because it only hits it once with a horizontal line doesn't mean it's a one-to-one function. It has to be a function first, and that's not a function. Okay, so we're going to use the definition of a one-to-one function to determine if the function is one-to-one. To use the definition, what we do is we say, okay, if f of a were to equal f of b, does that mean that a equals b? Because that's what the definition says. If we go back here, it says for a one-to-one function, if a does not equal b, then f of a does not equal f of b, or equivalently, if f of a equals f of b, then a has to equal b, or it's not one-to-one. So what we're going to do here is we're going to use that definition to show whether each of these functions is one-to-one. So we've got this function f of x, 2x minus 3. Let's say that f of a equals f of b. What is f of a? 2a minus 3. And what is f of b? 2b minus 3. Does that mean that a has to equal b? If it does, then yeah, this is a one-to-one function because that's what the definition of a one-to-one function says. Well, if I add 3 to both sides, that goes away. 2a equals 2b. Divide both sides by 2, and you get a equals b. That has to be. I mean, that's algebra. Okay, we didn't do anything illegal. If f of a equals f of b for that function, then a necessarily equals b. And so yes, that is a one-to-one function because it fits the definition. For part B, you've got f of x equals x squared plus 1. We're going to find out if that is a one-to-one function. And if you think about it, you know it's a parabola, so it's definitely not one-to-one. But we'll use the definition like we said we would. Let f of a equal f of b. That means that a squared plus 1 equals b squared plus 1. Does this mean that a has to equal b? Well, if we subtract 1 on both sides, we're going to have a squared equals b squared. We'll have to take the square root on both sides now to get a by itself, and that will be a equals plus or minus b. This does not guarantee that a has to equal b. It could also equal negative b. So this does not live up to the definition of a one-to-one function. In order for a function to have an inverse, the function must be one-to-one. And that's why we even mentioned a function being one-to-one, because we need to have those kinds of functions in order to find the inverse of a function. What is the inverse of a function? Well, let f be a one-to-one function, then g is the inverse of f if the following conditions are both true. F circle g of x is equal to x for all x in the domain of g. G circle f of x is equal to x for all x in the domain of f. So these are the conditions for two functions to be inverses. If this is true, then yeah, they're inverses. So two functions are inverses of one another if one of the functions undoes the other. Okay, that's what we're saying with 1 and 2 there. We're saying f of g of x, if you put the g of x function into the f of x function, you just get x again. It undoes whatever f did to it. What I mean by undoes is just like what I've said in the past about addition and subtraction. If you add 5 to a number like 3 and get 8, subtraction will undo what you just did. Take the 8 and subtract 5 and you're back to where you started. You undid the adding of the 5 by subtracting it. Multiplication and division are also inverse operations. If you multiply a number by 5, like 3, you get 15. If you then divide the 15 by 5, you get the 3 back. So these are called inverse operations, and this is the same kind of thing we're going to talk about with functions. A function that is the inverse of another function will undo whatever that function did to x. So the characteristics of inverse functions: if f and g are inverses, the domain of f will be the range of g. So the range of f will be the domain of g. If f is the inverse of g, then g is the inverse of f. That sounds obvious, but it's not always obvious. Just because a dog has 4 legs doesn't mean that everything with 4 legs is a dog. It doesn't always go both ways. But it does in this case. Given a function f, we often denote its inverse as f with a little -1 sign up there. Do not confuse that with an exponent. That just means f inverse. That's how we would say that. So given a function f and its inverse g, the definition implies that f circle f inverse of x is equal to x, and f inverse circle f of x is equal to x. So when you put one of the functions into the other one, you just get x because it undoes whatever the function did to x. Graphs of inverse functions will be reflections of one another across the line y equals x. And that's because the domain and range get swapped. So you can see in this picture, this graph, whereas one line has the point 180, the other line has the point 80, 100. So the domain and range have been switched. Okay, so we're going to determine whether the functions are inverses. And the way we do that is to take one of the functions and plug it into the other function and see if you get x. So if you put a number into this function, it will multiply the number by 12, and then it will add 100 to it. That's what that function does. So we're trying to figure out, if I do that, if I stick a number into that f function, and then whatever I get, I put that into the g function, will it just turn back into x again? Because it undid whatever f did to it. So it has to go both ways. We have to check both situations. So what we're going to do is we're going to say f of g of x. We want this to equal x. So I am going to plug in the g of x function, x minus 100 over 12, into the f function, 100 plus 12x. So where I see an x, I'm going to put x minus 100 over 12. So that equals 100 plus 12 times x minus 100 over 12. And you can quickly see that, yes, that does equal x. All right, now I'm going to do it the other way around. I'm going to say g of f of x. I'm going to put into the g function 100 plus 12x. That will be the x I'm putting in. And so that will be 100 plus 12x minus 100 over 12. And again, you can see that that's 12x over 12, which is x. Those are inverse functions. All right, let's check and see if h of x and k of x are inverse functions. So first of all, we'll just take h of k of x. We'll put that k function into the h function. So the h function is the cube root of x minus 1. Our x is going to be k of x, which is negative 1 plus x cubed, and then minus 1, because that's what h does. And that gives us the cube root of x cubed minus 2. And that does not equal x. So these are not inverse functions. You don't even have to check the other way because they're not. Okay, now, how do you find the inverse of a function if you just have a function and you want to know what is the inverse? All right? It's not too hard to do. All you have to do is, first of all, replace f of x by y, then interchange x and y, then solve for y, and then change it back into f inverse of x. So let's just do that. All right, we're going to look at this function, f of x equals 3x minus 1, and we're going to find the inverse of that function. So we're going to replace f of x with y. So we'll just call it y equals 3x minus 1. And now we're going to interchange x and y. So wherever I see a y, I'm going to put an x. And wherever I see an x, I'm going to put a y. Now I'm going to solve for y. So I'm going to add 1 to both sides. 3y equals x plus 1. And then I'm going to divide both sides by 3. And that's going to give me y equals x plus 1 over 3. And now, instead of calling it y, I'm going to call it f inverse of x, because this is supposed to be the inverse of x. All right, and just to show that it really is the inverse of x, we'll go back and try what we did on the previous slide. We will plug this inverse function into the original function and see if we get x.
So f of f inverse of x is equal to 3. So 3 times x plus 1 over 3 minus 1. And that is just going to be x plus 1 minus 1, and that is x. So that works. Let's do it the other way. F inverse of f of x. Now I'm going to put this into the inverse function. So that's going to be 3x minus 1 plus 1 over 3. And you can quickly see that that is x. So these two functions are inverses, and that's how you find the inverse of a function.
Okay, write an equation for the inverse function for the one-to-one function defined by f of x equals 3 minus x over x plus 3. All right, so we're going to follow those rules. We're going to change f of x to y, and then we are going to just write it again, 3 minus x over x plus 3. Now, everywhere we see an x, we're going to put a y, and everywhere we see a y, we're going to put an x. And now we have to solve this equation for y. So I'm going to multiply both sides by y plus 3. Multiply xy plus 3x is equal to 3 minus y. And now I want to get everything that has a y in it on one side and everything else on the other side. So I'm going to add y to both sides. And now I'm going to factor out the y on the left. Y times x plus 1 is equal to negative 3x plus 3. And now to get y by itself, I'm just going to divide both sides by x plus 1. And so my inverse function now is going to be this. So f inverse is equal to negative 3x plus 3 over x plus 1. All right, given m of x is equal to x squared plus 4 for x greater than 0, write the equation of the inverse. The reason it says x is greater than 0 is because this would not be a one-to-one function if we were talking about all x's, because this is a parabola. You should recognize it, x squared plus 4. And so if we used the horizontal line test on that, it would not be one-to-one. But since we're saying we're only looking at this part of it, then it is one-to-one because, yeah, it only goes through once. So we're just looking at half of the parabola, just the part where x is greater than or equal to 0. And so we're going to say, write the inverse. So we're going to change this to y equals x squared plus 4. And then we are going to interchange the x and y. So x equals y squared plus 4. And now we want to isolate y. And to do that, we're going to subtract 4 on both sides. So we'll have x minus 4 is equal to y squared. And now we're going to take the square root on both sides. So the square root of x minus 4 is equal to y. And I don't have to put plus or minus because, like I said, we're only using the positive values here. So y is equal to the square root of x minus 4. So m inverse of x is equal to the square root of x minus 4.